like real fast. And then I guess maybe we need to like just get even bigger casting machines. Sure, why not? You know, down, yeah, let's 50,000 tons.
BYD may surpass Tesla in sales, but when it comes to vehicle manufacturing technology, they will never catch up with Tesla. Elon Musk has introduced a gigantic casting machine, about the size of a house, even larger, that can produce a car frame in just a few seconds. Elon Musk calls it a giant version of a Matchbox toy factory. This machine can even cast 5 vehicle frames at the same time. It may sound unbelievable, but it's absolutely true. Tesla is the first company in the world to use the Gigapress and integrate it into an electric vehicle production line. Although other automakers have tried to follow, none have been able to catch up because Elon Musk keeps upgrading the machines. It all started with the 6,000-ton Gigapress, used to produce the rear underbody of the Tesla Model Y. Then came the 9,000-ton Gigapress, specially designed to cast the body of the Tesla Cybertruck. You need to understand that a 9,000-ton press is already enormous. So why does Elon Musk need even larger casting machines with clamping forces of up to 50,000 tons? As always, we respect your time. So let's get straight into this new Gigapress machine. How exactly does this machine transform the production line for those unfamiliar with Tesla's Gigapress? It's a high-pressure die casting machine that Tesla imported from an Italian company called Idra, which was acquired by LK Technology in 2008. This machine allows for casting the entire front and rear frame in a single pass, instead of welding each joint individually, which is very time-consuming. Right. The story begins when Elon Musk was working on the Model Y. Tesla wanted to revolutionize the way the Model Y chassis was manufactured, but they didn't have the right equipment. Elon Musk contacted leading die-casting machine manufacturers. We recall about 6, but most refused the Tesla CEO's request, believing he was looking for a machine no one else could build. However, a miracle happened at the last minute when, on his final contact, Elon Musk reached Idra, and they were also researching and developing a giant die-casting machine. And coincidentally, that was exactly what Elon was looking for. You might not believe it, but thanks to the Gigapress, Tesla can reduce a vehicle's weight by up to 25%. That's why the Cybertruck and Model Y are significantly lighter than other vehicles in the same class that rely on traditional welded frame construction. In addition, the Gigapress increases structural rigidity and improves efficiency by casting a single large component instead of welding together dozens of smaller parts, saving both time and labor. Everything begins in the smelting furnace, where aluminum alloy is heated to extremely high temperatures until it becomes a glowing stream of molten metal. This molten aluminum is then poured into a gigantic metal mold that has been precisely designed in the exact shape of the part being produced. For example, a section of the car's chassis. At that moment, the Gigapress reveals its true power. The massive machine generates enormous pressure, forcing the molten aluminum to flow into every tiny corner of the mold. There is no room for error. Every detail, every curve must be perfectly filled. But the challenge is not only about power, it's also about timing. If the process happens too quickly, air bubbles can form inside the metal. If it happens too slowly, the aluminum will begin to cool and solidify before it fully fills the mold. That's why the entire process must be calculated with precision down to the very second. Once the mold is completely filled, a specialized cooling system begins operating, lowering the temperature evenly so the aluminum alloy solidifies into its final shape, both strong and extremely precise. When the metal has fully formed, industrial robots quickly open the mold, remove the newly cast component, trim off the excess material, and move it to the quality inspection stage, in a single process, starting from molten metal. The Gigapress can create a large and complex structure that previously had to be assembled from dozens of different parts. Just a few years ago, Tesla was the only company with this technology. But by 2026, it has been adopted by several major automakers such as General Motors, Hyundai, Volvo, and Speng. They are all investing heavily in this technology because every manufacturer wants their vehicles to be produced faster, cheaper, and with better quality. For example, Xpeng deployed a 16,000-ton Gigapress last year. So why does Tesla need even larger die-casting machines from 6,000 tons to 9,000 tons, and then suddenly jumping to 50,000 tons? You know, there is clearly a reason behind this upgrade. When Elon Musk first mentioned the idea, many people immediately raised a series of questions. How large would a machine with such enormous pressing force actually be? Where would Tesla place it inside the factory? How long would installation take? And would it really be powerful enough to create multiple vehicle structures in a single casting? If the information that has been revealed is accurate, this could become one of the most impressive pieces of manufacturing equipment ever seen in the automotive industry. Musk said that production lines using the new generation of Gigapress could operate at speeds that humans can barely keep up with. The entire process, from pouring molten metal, cooling the mold, to separating the finished part from the mold, is fully automated by robots. Even more astonishing, each casting cycle takes only about 5 seconds. That means a large section of a vehicle frame can be created in roughly the time it takes you to blink a few times.
I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa. The design of the Cybercab line, it doesn't look like a normal car manufacturing line. It looks like a really high-speed consumer electronics line. In fact, the line will move so fast that actually people can't even get close to it.
If this technology reaches full commercial scale, it could transform car manufacturing, an industry that once required hundreds of parts and numerous assembly steps, into a process that is fast, streamlined, and almost seamless. You can imagine that a 50,000-ton Gigapress would be about 3 times larger than the 9,000-ton Gigapress used for the Tesla Cybertruck. As we mentioned earlier, it could easily be bigger than an entire house laid horizontally around 65 feet long, 40 to 49 feet tall, and roughly 32 to 39 feet wide. These are just estimates, but its scale would be roughly that massive. Tesla would install the machine piece by piece, and the assembly process could take close to 1 year. That is understandable, considering that even XPeng's 16,000-ton Gigapress required nearly 120 days just for installation. This machine will be integrated into Tesla's Unboxed Process production line to manufacture the entire body frame of the Tesla Cybercab in a single casting. In fact, it could cast 5 underbody sections of this vehicle in one cycle. This is also the point that is easiest to misunderstand. You might think a larger machine simply means higher productivity and faster casting speeds. That is true, but it is not the whole story. Interestingly, the operating mechanism of the 50,000-ton Gigapress is not fundamentally different from the 6,000-ton or 9,000-ton versions. As we know, most Tesla vehicles use aluminum chassis or body frames, and the Cybercab is no exception. With the new Gigapress, the process begins by melting new aluminum ingots together with leftover aluminum from previous castings in a furnace heated to about 850 degrees Celsius. After that, any surface impurities are removed before the molten metal is transferred through heated pipes into another sealed furnace, where the temperature is maintained between 750 degrees Celsius and 850 degrees Celsius. The new Gigapress uses a 2-furnace system to process the aluminum alloy. One furnace acts as the melting furnace, powered by natural gas and operating at around 850 degrees Celsius. The other furnace holds the molten metal and is heated electrically, maintaining a temperature between 750 degrees Celsius and 850 degrees Celsius. Electricity helps keep the temperature stable and produces no smoke or steam, allowing the aluminum to remain denser and structurally stronger. But it doesn't stop there. The empty space inside the holding furnace is filled with nitrogen gas, which prevents oxide from forming in the molten aluminum and helps maintain a stable temperature. In addition, technicians use argon gas, a rotary degasser, and silicon carbide filters to remove further impurities and particles larger than 25 microns. Once the aluminum is fully melted and purified, the 50,000-ton Gigapress automatically moves to the next stage, lubricating the mold surface. This is where things get particularly interesting. A robot sprays about 35 milliliters of soybean oil as a thin, even layer across the mold. Yes, it's similar to greasing a baking pan so the finished product can be removed easily without sticking. After that, the system creates a vacuum to remove any remaining air, and the molten aluminum is transferred from the holding furnace into the shot chamber of the Gigapress. There, the molten metal is injected into the mold cavity by a high-speed piston. This piston is also lubricated with about 8 milliliters of oil before each injection to prevent the aluminum alloy from sticking or clogging the system. After the molten aluminum has completely filled the mold, it is held tightly in place until it solidifies. When the casting is released from the mold, it is still glowing red at around 400 degrees Celsius. Immediately, a robotic arm drops it into a cooling water bath. This thermal shock, from 400 degrees Celsius straight down to about 50 degrees Celsius, is not just about cooling the part. It is the key step that locks the aluminum molecules into place. eliminating defects and creating a much stronger and more rigid vehicle frame.
So I mean, we got to jam the liquid metal in, cool it down real fast, like real fast.
Meanwhile, the gigantic mold that has just opened also needs attention. Robots quickly clean it and cool it down to about 185 degrees Celsius, preparing it for the next cycle. The entire process runs so smoothly that every 1 to 2 minutes, a new vehicle frame is produced, an astonishing speed compared to the traditional method of welding together hundreds of steel pieces by hand. Of course, nothing goes to waste. Every leftover piece of aluminum trimmed from the casting is sent back to the melting furnace to be reused in the next cycle. To ensure absolute safety, each cast frame must pass through an X-ray inspection system after leaving the line. This all-seeing eye scans deep inside the structure to make sure there are no trapped air bubbles or microscopic cracks, guaranteeing that the vehicle's structure is as solid and seamless as a single block of metal. The biggest challenge of this process is keeping the mold from shattering under the enormous pressure of the molten aluminum flow. That's why the press must generate a massive clamping force of up to 50,000 tons to keep everything firmly under control. According to Elon Musk, turning this seemingly impossible idea into reality required Tesla to design an entirely unique technological ecosystem. From a supercooling system to an intelligent mold release mechanism, and even AI-based quality inspection processes. It's a combination that no other automaker has ever attempted on such a large scale. This step marks a historic milestone, as the automotive industry begins to shed its heavy mechanical manufacturing approach and move toward a model more like consumer electronics production, ultra-fast, streamlined, and optimized for space with extreme efficiency. The biggest psychological barrier to gigacasting technology today is the belief that if the vehicle frame is a single piece of aluminum, then if one spot is damaged, the entire car has to be scrapped. Yeah, we've read plenty of comments like that. Under traditional thinking, a steel frame welded from hundreds of small pieces has the advantage of cut out what's broken and weld in a replacement. However, at this point, Tesla and several other automakers have turned this supposed disadvantage into a highly sophisticated modular repair system, completely changing the landscape of vehicle maintenance. Instead of casting the entire underbody as one continuous piece from front to back, modern designs divide the vehicle structure into 3 strategic sections: the front, the center, and the rear. In this setup, the crumple zones at the front and rear are engineered to function like physical fuses. They are bolted to the main cast structure using specially designed load-bearing joints rather than being permanently welded. When a low or moderate speed collision occurs, only these sacrificial modules deform. Technicians no longer need to use welding equipment or frame-pulling machines to realign dozens of small steel parts procedures that can compromise safety. Instead, they simply unbolt the damaged section and replace it with a new module manufactured to precise specifications. This shift is also helping break the stereotype that electric vehicles inevitably come with extremely high insurance costs. According to a 2025 report from Thatcham Research, a large cast structure actually reduces the complexity of damage diagnosis. With traditional welded frames, a collision may quietly loosen hundreds of weld points or spread adhesive bond failures, forcing technicians to dismantle large portions of the vehicle to inspect it properly. By contrast, a cast structure is far more transparent. It is either intact or the crack or fracture is clearly visible. Combined with sensor-based diagnostic tools and handheld X-ray devices used in repair shops, the extent of damage can be identified almost immediately. Estimates suggest that vehicles using gigacasting could reduce shop time by up to 30%, directly lowering labor costs, currently the largest component of most repair bills. The bolting instead of welding revolution goes beyond economic efficiency. It also elevates the entire philosophy of vehicle maintenance. Cast frames provide extremely stable mounting points for the suspension and powertrain. After a damaged crash module is replaced, the vehicle can return to almost 100% of its original geometric precision, just like when it left the factory, something traditional manual straightening and welding methods rarely achieve. It's fair to say that gigacasting is transforming auto repair from a largely craft-based, intuition-driven trade into a high-precision assembly industry. This shift is a key reason insurance companies can feel more confident lowering premiums, while owners can feel reassured that their vehicles are not fragile at all. If anything, they are more durable and easier to restore than ever before. If the Model Y once stunned the industry with the ability to roll a completed vehicle off the line every 30 seconds, the Cybercab is preparing to shatter that figure. Thanks to an improved Giga Press system, each Cybercab chassis can now be completed in just 5 seconds. Simplifying the structure from hundreds of welded components into a single cast piece not only increases rigidity, but also eliminates major bottlenecks in the production line. At this pace, Cybercab is poised to become the fastest produced vehicle in Tesla's history, setting an entirely new benchmark for the global automotive industry currently. Developments at the Texas factory show that Tesla is going all in on its goal of mass production next month. Images of 14 Cybercabs in a luxurious metallic gold finish, neatly lined up outside the factory exit, offer the clearest glimpse yet of the vehicle's futuristic design, fully autonomous, with no steering wheel, no pedals, and none of the traditional control buttons. The surge in the number of test vehicles, reaching dozens in early March, is the result of Tesla's unboxed manufacturing method. Instead of moving a large vehicle body through the entire production line, Tesla breaks the car into separate modules that are assembled simultaneously and only later joined together. This process maximizes cost reduction, shrinks factory footprint, and enables significantly faster assembly than conventional manufacturing methods. Yeah, Elon Musk and Tesla employees certainly have reason to celebrate. What's happening at the factory isn't just the production of a new vehicle, it's the operation of the machine that builds the machine at extraordinary efficiency. Once this large-scale pilot production phase is complete, the Tesla Cybercab will be ready to flood city streets, ushering in an era of low-cost, ultra-fast autonomous transportation. The Tesla Cybercab aims to be priced below $30,000. It is not just a new product, it represents a strategic shift for Tesla toward the era of autonomous transportation, designed specifically for robotaxi fleets. Cybercab reflects the company's ambition to build a fully automated mobility ecosystem where software, artificial intelligence, and robotics play the central role. However, from our perspective, this excitement should be balanced with a more realistic view. Cybercab still needs to overcome several critical hurdles. These include perfecting its autonomous driving software, complying with complex regulatory frameworks, and building a large enough supply chain to support true mass production. Even so, the ramping up of production activity at Gigafactory Texas shows that Tesla is not stopping at the concept stage. The company is gradually turning its vision of a large-scale robotaxi network into reality. If factory expansion and manufacturing optimization continue on schedule, the coming months could become a decisive phase, determining how quickly the Tesla Cybercab begins appearing on streets across the US and eventually in international markets. So, do you believe Gigapress is the future of all car manufacturing? Drop a comment below. That's all we wanted to share in today's episode. We hope you now have a better understanding of Gigapress and the Tesla Cybercab robotaxi. Thank you, and see you next time.